This last part of the video with this lesson, you'll see is graphing quadratics using a table and discussing the domain and range. So these next few problems we'll look at are equations that you would want to type into your calculator, and as you're doing that, and as I'm doing that, I go to y equal, and I'm typing in this equation. And then what I want to go to is second graph. And what that's going to allow you to do is that's going to allow you to create a table of data points that will allow you to graph it and sketch it. So to do a quick sketch here, it's what I would ask you to do on your graph paper, just on your notebook paper, is in order to sketch this, I need some data points, but I also know that I've got a vertex of -2, -6. Now we're going to notice with quadratic equations, it's going to open up or it's going to open down in regard to functions. So with functions, it's going to open up or open down, and it's going to open up due to the a value being positive. You would see that once you graph it. So a quick sketch of so if I graph the vertex, that's -2, -6. That just means that this point up here, that's the vertex. It's the lowest point, or it's the highest point. So if -2, -6 is the vertex, then -3, -4, and -1, -4. So you're going to start to see symmetry. These are some points that I'm just pulling from my data table. So -1, -4, -2, -6, and -3, -4. And so these would be, I'm just gonna do that again using a table. So I've got X and Y, and so I'm just going to use -3, -4, -2, -6, -1, -4. Those are 3 data points. We can also look at 0, 2. So this point right here. And then we can also look at -4, 2. And just freehand that best you can on your graph paper or on your notebook paper, and you've got and I could probably put this right up here in regard to numerical order. I just left that out. So about 5 data points, X and Y points, that'll allow me to see a picture of the graph, and you can see that it creates a curve and that this is your vertex. And we'll get specific on how to calculate that later on in the semester, but in this case I gave it to you, and now I want to know what the domain and range would be. So the domain, it's just your X values. What are all the possible X values on this graph? And since it's going on forever up, and it's going on forever up this way, that means the more X values you choose this way, they're on the graph way above. And the more X values you choose to the left this way, they're on the graph above. So what we would say in interval notation, we would say from negative infinity to positive infinity. That would be the domain. The range, however, are the y values. And those are going to be specific because now you're looking up and down on the graph, because here's the domain is left and right on the graph, and the range would be up and down. Well, notice that the graph goes up forever, but it does have a minimum point, and that minimum point would be that y value in the vertex. So the minimum point would be -6, and I'll write that again. And we're going to use a bracket because we're including this value. And then I'm going to write to positive infinity. So the domain, all real numbers from negative infinity to positive infinity. And the range are the y values. And it has a minimum point with -6. So -6 is going to be part of our range. So we type in a new equation to your y equals, so -3x squared plus 6x plus 5. And you go to your table, and we would see, I'd like to create a t-table here. And I could see from -1 to -4. -1 for x, -4y, 0, 5, 1, 8, 2, 5, 3, -4. Notice that the vertex is 1, 8, and notice that there it is in my table. So I've put it in my graphing calculator, and so just ask you to sketch it. Not everybody has graph paper, but on the quiz, I will provide you with a little grid that you're allowed to plot as many data points as you can. So I'm going to go over to -1, 1, 2, 3, 4, plot this point, and then 0, 5, so 0, 1, 2, 3, 4, 5. We'll plot the point 1, 8. That's 5, 6, 7, 8. 2, 5. 1, 2, 3, 4, 5. This point right here should actually be here. And then 3, -4. So sketching that, we're going to max out at 1, 8 and come back down. So notice this point, we have a maximum point, and it's at 1, 8. So when I ask for the part B, when I ask for the domain, D:, the domain would also be from negative infinity to positive infinity. So the x values that I continue to choose left and right, I can choose as many x values this way, there will be a y value. Many x values this way, there'll be a y value. Now, again, your range will involve this 8. So the first number or representation in the parentheses for domain and range represents your least amount. Well, the least amount is going this way forever, so that would be negative infinity. And then it's going to increase, and it hits a maximum of 8, and we include it. So there's my domain and range. Here's my data table. Here's my graph. So you go to your y equal, you type in 3x squared minus 5. And you go to your second graph. And I'm going to write my data points for X and Y. And I'm going to write -2, 7, -1, -2, 0, -5, 1, -2, and 2, 7. So I'm going to plot those as a sketch. And -2, 1, 2, 3, 4, 5, 6, 7. So there's -2, 7. There's -1, 2. There's 0, 1, 2, 3, 4, 5. There's 0, -5. And here's 1, -2. And this one should have been -1, -2. Sorry about that. And get my eraser. So -2, 7, -1, -2, 0, -5, 1, -2, and 2, 7. So carefully just connect those the best you can. Try that again. So there's my data points. Here's my sketch. And so my domain would be -infinity to +infinity, be all the possible X values, all the possible Y values. The range is going to be specific. It's coming from this -5 because it has a minimum value. And in the interval notation, the number that comes on the left first is your smallest value. So that would be -5, comma, +infinity. And there's your domain and your range. Go back to your y equal, and you'll type in -2x squared minus 8x minus 4. And get my set of data, X and Y. So I'm going to go to second graph. And I know my vertex is -2, 4. I'm giving you that right now. We don't have to calculate that because I want you to practice on your writing your domain and range. We'll do more calculating of that later in the semester. So -2, -4. So I'm going to choose -4, -4, -3, 2, -2, 4. There's the vertex. -1, 2. You should start to see some symmetry in your table. And 0, -4. We're going to sketch that. And we'll plot -4, -4. So 1, 2, 3, 4 in the negative. 1, 2, 3, 4 in the negative. So -4, -4 would be right here. -3, 2. 1, 2, 3 in the negative. 2 in the positive. -2, 4. -2, 1, 2, 3, 4 is where it's going to peak. -1, 2, and 0, 1, 2, 3, 4. So graph should look something like this. And the domain, again, would be -infinity to +infinity. And the range would have a minimum value that's going this direction. So the minimum would be to negative infinity, and the positive would be the y part of your vertex, 4, and we would include it. So this is really the new part that I'm asking you to find a sketch. We can find all this from the calculator, but the domain and range, part of that does come from our vertex. So check for understanding would be, we've got our rectangle, and so the length of the rectangle is 4 meters less than 3 times the width. And there's your width, and there's your length. And we know what the area is. It's 160 meters squared. So we're going to say x times 3x minus 4 is equal to 160. So 3x squared minus 4x. And I'm going to subtract the 160 and set it equal to 0. Now, I cannot factor 3 out of everything. So what I can do is multiply the 160 times 3, and I get negative 480. And I'm looking for 2 factors that multiply to give me negative 480, but the difference is going to be negative 4. So one way we could do that, we mentioned, is we can go to our graphing calculator and go to y equal and type in 480 divided by x, and then go to second graph and look at the data table. And you're looking for xy values that would give us a difference of 4. And it looks like it's going to be 20 and 24. They both multiply to give us negative 480, but this would have to be negative, and this one would be positive. That would give us the sum of negative 4, but the product of negative 480. So a is not 1, so 3x squared minus 24x. Remember, the negative 24x is coming from here, plus the 20x, which is coming from here, minus 160. And now we're just going to group and find out what they have in common. So this looks like it would be 3x. So that would be x minus 8. And 20 and 160 looks like it would be 20. So that would be x minus 8. So you have 3x plus 20 equals 0, and x minus 8 equals 0. And this is the only one that's going to work, is when the width is 8. So that would go here. So the width would be 8, and 8 times 4 is 24, and 24 minus 4 is 20. So you got a length of 8 and a width of 20. Number 2, you want to determine the solutions. So 2x squared plus 5x minus 25. I cannot factor a 2 out of each of the terms, so I'm looking for a times c, and that would be negative 50, and it's got to add to give me 5. So 2 factors of 50 that add to give you 5 look like it's going to be 10 and 5. This will need to be positive, and this one would be to be negative. So there's my sum to 5, but my product to negative 50. So since a is not 1, I'm going to rewrite the first term. And I'm going to write minus 5x, and then positive 10x minus 25 equals 0. Got my 4 terms. I'm going to group. Only thing in common here is x, so that'll be 2x minus 5. 10x and 25, GCF would be 5, so 10x divided by 5 would be 2x. 25 divided by 5 would be 5. So I actually have x plus 5 equals 0, and 2x minus 5 equals 0. So this is just an example of trying to find the solutions. So x would be negative 5, so it would be negative 5 comma 0. And this would be 2x, add the 5 over, divide by 2, you get 5 halves. So 5 halves, comma 0, or 2.5. And then finally, practice from what we've been doing. So we would type in 2x squared minus 4x minus 3 into your graphing calculator. Go to second graph to pull up a table. And we know where the vertex is. The vertex is 1, -5. So create my data table here of my x and y. And I'm going to choose points -1, 3, 0, -3, 1, -5, 2, -3, and 3, 3. These are just data points that would fit in a small window when given a graph. So I'll go ahead and plot those. That'll be -1, 3, 0, -3, 1, -5, so 2, -3, and 3, 3. So we see that it does bottom out. And it has a minimum point, and that minimum point is 1, -5. It's the vertex. So the domain would be -infinity to +infinity, and the range would be where it bottoms out at -5, comma, to +infinity. -5 meaning it's the smallest value on the graph, and then moves up all the y values up to the +infinity, and then all the x values. What are all the possible x values? To the left, infinite. To the right, infinite.